Right. While we wait for others very briefly, maybe for the next 10 minutes, let's quickly play with the icebreaker we have on the screen. I believe you can see the screen, right?
Yes, we can see it.
Okay, great. In the chat menu, just type 3 statements, and 2 of the statements should be true, while 1 is false. Just 3 simple statements about your experience so far, either with Python programming or with AI generally. So type 3 simple statements. 2 are true and 1 is false. So then the rest of us will try to guess which of the statement is false. So let's try to use that one to engage ourselves for the next 5 to 10 minutes before we dive into what we have for today. Okay, from Gloria, we have just one. You can use Shift Enter to actually go to the next line. Okay, I'm seeing the 2 statements from Gloria. I'm seeing 2, the second one. I have my own 3. So Leonard, what we are doing, okay, we have some other people joining us. You can see the message on the screen. We are quickly running through a simple icebreaker whereby every one of us, we type 3 statements on the chat, and then just 2 of the statements are true in reality, while 1 is false. So then other people will try to guess which of the statements is false. So that's what we're currently doing. We want to just use that one to while away time, maybe for the next 5 minutes or 7 minutes, so that we can wait for others to join. So while we do that, I have 2 statements already from Gloria. Okay. So we have three statements from Gloria already. And you have three from me as well. So let's wait for one more person to also drop so that we can then take a guess. Okay. Adewapo, you are to make three statements about yourself. And two of the statements should be true, while one is false. So we want you to type the statement in the chat. Three statements about yourself. Two are true, one are false, especially about your experience with AI and programming. I'm waiting for just one more input so that we can quickly. Okay, this is taking too much of our time. I think maybe we'll need to just work with what we have for now. Okay, very quickly. Can someone make a guess about Gloria's statements? These are the three statements from Gloria. Maybe let me see if I can put them on this slide.
I think for, is it Gloria?
Gloria, yes.
Gloria, okay. Number one, I have created Python script to aid the I think number one is not true.
Number one is not true. Okay.
Yeah.
Gloria, can you confirm or otherwise?
That's actually true.
Come again.
The first one is true.
The first one is true.
Really?
Okay.
Yeah, Brookhaven.
Yes. Can somebody make another guess? That's for Gloria. We have it on the screen. Yes. Can another person make a guess? Please, let's make it as participatory as possible. It will help us a lot today.
Prof, I think the second statement is not true.
Okay.
It is both easy and challenging at the same time. I find it a bit controversial.
Okay. Gloria, can you help us out?
I mean, I think it depends how you view it. Well, I mean, some people think Python is easy, so others think it's challenging. So I think it can be worked through and false at the same time.
Okay, but the point is the statement for you, is it true
For
or
me,
false?
it's true.
For you, it's still true. Okay. So
Yeah,
then we are left with the third option, right?
yeah,
Okay, so for you, the third option is not true, right?
yeah. The last is not true.
Okay, okay, that's all right. That's good. I think that's interesting. Okay, let me also paste from Leonard very quickly. So I have from Leonard on the screen. Can we just make it? So somebody make a guess very quickly.
I think the first one is true.
Okay. Can you confirm, Leonard?
Yeah, it's true. Yeah, she's correct.
Which
Yeah,
one is false?
I think the last one is false.
And
Okay, who
for
is
me, I
making a
think the
guess now?
second one,
Guess.
the second one is okay. For me, I think the last one it's true, and the second one maybe it's false.
Okay. So for Gloria, second one is false. And who is the other person saying
Well,
the
yeah,
third
Prof,
one is false?
I think
Yes.
the second, for me, I think the second one is true and the last one is false.
Okay, that's Elvis.
Yes, Prof.
Okay, can you please confirm for us, Leonard?
Yeah, the last person is correct. The second one is true. The last one is false.
It's false. Okay, I
Yes.
see. I'm teaching others Python programming. Okay. I believe after today, you should be teaching others Python programming.
Yeah, I can teach, but I
Yeah.
think I don't have someone now to teach, like somebody that need it. But I think I am
I
familiar
believe
with.
at the end of today, every one of us should be better. Okay. So let's have this last one. It is from Elvis. Okay. So can we make a guess?
I think 1 and 2 is true. 3 is false.
Okay. Another
Same thing.
guess?
I think that's also the same here. The first and the second is true. The last false.
Okay.
That's absolutely correct, Prof.
Okay. Okay. Service, have you confirmed that?
I confirm that they are correct, sir.
Okay, that's awesome. So, meaning very soon you'll be getting your PhD in ML and data science. And
Amen.
soon that will be true. Okay,
Amen. Amen.
that's all right. It's been a nice time going through this basic one. And I believe that has simulated our interests. We're going right away to what we have for today. I want to welcome every one of us specially. And I believe that today is going to be a very massive experience for every one of us. Delia solicited that we should connect with our computers so that we can have an all-encompassing experience. So very quickly, I would love to share my screen so that the way the program will be structured today, I have about 20-something slide I will just share with us briefly. After sharing the slide and discussing what we can gain from prompt engineering in improving our programming skills. Then we'll go right into hands-on. Why? We'll brainstorm, think of a problem we want to solve in our environment, and let's go prompting with AI and see what we can achieve and improve with our programming skill. It promises to be a rewarding experience for every one of us, and I want us to give it all the attention that it requires. So welcome once again. I believe we all know my name, but for the purpose of emphasis, I am Professor Akinlola Yinka, the convener of this webinar. It's my pleasure to always be here to support every one of us to actualize our goal. And as we go today, I believe each and every one of us, by God's grace, we add value and will definitely improve on what we know before. So please kindly confirm if you can see my screen.
Yeah, we can see it. It's clear.
See it. So we're looking at leveraging, and I believe it's legible enough, right?
Yes, it's okay.
Okay, perfect. Now, we're looking at leveraging AI prompt engineering to enhance our Python programming skills. We are dwelling within the domain of physics modeling perspective. But I must say, it is not limited to physics. Or if I'm saying physics perspective, I also believe physics is life. So if you are not primarily in the domain of physics, it does not in any way undermine your position that you can actually leverage on what we are doing today to achieve whatever you want to achieve, okay? So it's not limited to physics. It's actually useful for application in any area of human endeavor that you might think you want to explore, okay? Now, I will be talking on the following. I will just first of all look at the overview of AI. What is an AI? Just basic definition and talk about a few things that has to do with AI and why it is important, okay? Then I will also introduce myself to prompt engineering. It's a new domain that is coming up and it holds a lot of promises and it actually influences how best we can actually get from AI. Then prompting techniques, we'll look into that. Then we'll look at popular large language models like your ChatGPT and the rest of them. Then we'll look at Python programming with AI. We'll look at modeling basic physics concepts. Then we'll also look at maybe a little bit of advanced prompting. Then we'll look at quantum physics also basically within this presentation. I have some code snippets there. Then I will talk about best practices and then I will come to conclusion. Thereafter, we then proceed to hands-on experiences whereby we interact and have an experience that each and every one of us can actually contribute and share our screen as to what we want to do. So let's start very quickly and talk about what is an AI, okay? Artificial intelligence. It has come to stay, is already with us. We already have it with us. And so if you have it with us, what is it, okay? If you ask an average person, what is an AI? What comes to his mind is AI is ChatGPT. That's the most popular one that most people know about. But it's far much more beyond that, okay? So what is an AI? I've put a simple definition here. It refers to the simulation of human intelligence processes by machines, especially computer systems. So when we talk about artificial intelligence, what should come to our mind is that we are looking at a simulation of human intelligence, okay? We are looking at a machine trying to exhibit human intelligence, okay? Now, God created human and what human brain can do is enormous, okay? But this time around, rather than talking about human intelligence, okay, we are talking about the artificial intelligence that is not human, okay? What is human intelligence? It starts from when a child is born. In fact, right from the womb, okay? The human intelligence begins from when the child is in the womb. The okay? You will hear a pregnant woman say, oh, my baby is kicking me. Oh, this baby is restless, okay? That child is responding to certain inputs, okay? And based on that one, you are getting response, okay? That is human intelligence. You start developing from that stage. However, when we talk about artificial intelligence, we are talking about the simulated situation whereby the intelligence is not just human now. It's not just human intelligence, but what? Artificial. And this one is actually achieved by looking at the core area, core components of what makes up an AI. What are those core? We talk about learning. You cannot be talking about artificial intelligence without going through the process of learning, okay? So machines are made to learn, okay? Based on what has been established by human intelligence through verifiable data, okay? So when we talk about artificial intelligence, the basic core, the basic foundation, you'll be talking about data. And so the learning here is ability to be able to acquire and then thereafter improve knowledge from data. The data we are talking about, we're talking about data gathered through empirical evidences, through human intelligence or otherwise, okay? And so we cannot underestimate the role of data, okay, in artificial intelligence or machine learning, okay? When the machine wants to learn, the quality of your data is what we actually determine the quality of the knowledge your artificial intelligence will have. That is the aspect of learning, okay? Then when we talk about reasoning, now, there is need to now draw conclusions from what? From rules and facts based on the learning that has taken place. That's when the reasoning comes in, okay? So the artificial intelligence has the core of being able to what? To reason now. Because it has it has gone through the process of learning. You know, human intelligence also has go through the process of learning stages. Okay, if you watch how children grow, at a certain point in time, the child cannot climb the chair. Okay, the child begins to crawl. As the child grows, the child will devise a means. Okay, instead of climbing this chair from this angle, then I should have been able to climb it more easier from this other angle. Okay, that is intelligence. Oftentimes, a child may be crying when he's on a chair at a certain point in time because the child cannot come down. But after some time, the child will learn, okay, I need to turn and use my back to come down from the chair. That is the process of learning. And it continues all through human endeavor. What we are going through today is part of acquiring more human intelligence, okay? And that also takes place in artificial intelligence. So we have that ability to be able to continue to learn, and based on the learning, the reasoning takes place to be able to what? To draw conclusion from rules and facts. Then we have perception. Perception talks about being able to interpret sensory inputs such as vision, sound, and touch. I did mention earlier, considering a pregnant woman that is talking about, my child is kicking me, okay? Oftentimes, the child might be sleeping and be docile, and when you play music around where the pregnant woman is, the child begins to kick much, and the child is responding to what? To the sound, okay? The child is responding to what? To the sound, and so you see a lot of response going on there. Then we then have the final one, which talks about what? Problem solving, finding solutions to complex tasks and goals. That is what is happening as far as artificial intelligence is concerned. Now, what is prompt engineering? Prompt engineering, as we all know, we have several large language models. You will be seeing a list of them later in this presentation. We have so many of them. Are you getting me now? But the fact remains that majority of individuals using internet are not actually getting the best from this large language model that are made available. Why? Because we are not providing the right prompts. So what is prompt engineering? Is the art of crafting inputs to obtain desired output from AI system. You know, the basic thing we were taught about computer is garbage in, garbage out. We call it GIGO, garbage in, garbage out. Whatever your input is will definitely influence what your output is. So this is also applicable to your artificial intelligence. Even in as much as your machine or your model is intelligence, okay? No matter the level of intelligence of your machine or your model, the prompt you provide will go a long way to influence the kind of output you will get from it, okay? And some of these things, we'll try it out and see what it looks like, okay? So there is need to develop that prompting engineering skills to be able to provide succinct, accurate, correct, and then reasonable prompts that will provide the desired result from any AI model system you might be dealing with, okay? Now, it guides AI to generate high-quality code, explanations, and models, okay? It guides AI to generate high-quality code, explanations, and models. So prompt engineering is what guides the AI model that have been trained to generate any form of output. Like you need that quality code, you need explanations, you need a particular model. The prompt provided will go a long way to influence what you will get from it. So it's a very important aspect of interacting with AI. And it's not something that is an evolving field, it's still growing, it's an emerging field. And so A lot of us need to actually develop some of these skills so that we can get the best from various AI models that are available around us. And number 3, helps users control scope, accuracy, and relevance of results. Okay? It helps you as a user of an AI model to control the scope, accuracy, and the relevance of your results. Okay? I will try to be a bit faster so that we can have enough time for answer. Now, what is the motivation behind prompt engineering? What is the motivation? Why prompt engineering? Number 1, you have AI tools, so many of them, that can generate functional Python code. It will give you complete Python code. Okay? You know, the last 3 months in a webinar, we hosted Mr. Jeffrey from US, who was teaching us the basics of Python programming. It was an awesome experience we had with him. Are you getting me now? Those basic knowledge are very key and essential for you to delve into it. Okay? But beyond knowing those basics, is that okay? These days, AI can assist you to generate functional code using tools like a ChatGPT. You have Copilot, you have DeepSeek, you have QN, and then a cloud. These are all models that have been deployed publicly that can actually be used to achieve a lot. Then, why prompting engineering again? With well-engineered prompts, as a user, you can generate physics simulations conveniently. You can learn programming constructs. You can understand code section line by line. You can actually have, if you have an existing code, maybe written so many years ago, and you just find it in your archive. For somebody like me, during my master days, I wrote some Fortran programming programming. If I pick them up today, of course, they were not well commented, so I may not be able to relate with it. But if you have such a code in your archive and you give it to any of these large language models for it to check through the structure and provide comment, explanation of each of the line of the code, is able to do that one for you, giving the right prompts as you are giving that code. It can also help us to debug and optimize our code. And lastly, it enhances both learning and productivity. Now, the reality of it is this. When we talk about learning, learning is a continuous process. It doesn't stop. Like the popular saying, when someone stops learning, then the person starts dying. Okay? And I believe that is true because we keep learning. Even in our old age, we keep learning one or two things. Then in terms of enhancing our productivity, of course, what you will ordinarily do in 1 week, okay? With AI tools around you, you can get it done in 1 day or even in hours. That is, it will definitely enhance our productivity. You can master it very well. Effective prompting. Now, how do we go about it? The strategies for effective prompting. Number 1, we need to start with simple prompts. Simple prompts. Don't forget, most of these AI models, they are interactive in nature. Okay? So you can begin with a simple prompt and then begin to ask a follow-up question or provide a follow-up prompt as you interact with the AI. Okay? So begin with simple prompt. That is, start with a basic request before gradually adding complexity. So in the course of starting with simple prompts with an AI interaction, the AI is already being tailored towards the domain where you want to operate. So by the time you introduce complexity, the AI is already within the domain where you are speaking from. And so it's easier for the AI to actually adapt and then flow there. Then number 2, you have to be clear and specific. Clarity and specificity is essential. There's need to avoid every form of ambiguity when you are interacting with an AI. Somebody will say, I'm not getting anything from ChatGPT. You are not getting anything from ChatGPT because your prompting ambiguous. Your prompting cannot give you effective outputs. Okay? Number 3, there's need to set constraints and output formats. There has to be specific constraints. Okay? For instance, now, you can't just put a prompt and say, give me I need a program to do, I need a program to simulate solar radiation in Nigeria. That is not specific, okay? Program, what type of program, in which programming language? Okay, so there has to be specificity, okay? Then number 4, They have to encourage step-by-step reasoning, okay? Prompt the AI to explain its thoughts, process, or logic sequentially, okay? Step-by-step reasoning, give that benefit whenever you are prompting, okay? Now, let's look at this example, for instance. We have the kinetic energy equation, okay? Energy is equal to half mv squared. We are all familiar with this, okay? Now, if we need to write a Python function to solve this particular kinetic energy equation, so a typical prompt could be write a Python function to compute kinetic energy given mass and velocity. And something like the output you have on the screen here can come out, okay? A different way to go about it is that you can actually say, okay, write a complete Python programming to compute kinetic energy given mass and velocity, okay? You can also write another prompt and say, write a complete Python program to compute kinetic energy given mass value from so to so at a given velocity. Meaning you want to check how the kinetic energy can vary as a function of what? Mass. Okay? So these are some of the prompting you can give, and you begin to see how you can actually relate and do some of these things. Now, what are the major large language models that we have around? Number one, we all know the OpenAI ChatGPT, okay? The large language model, LLM, that is being used is GPT-4. So they have GPT-Ho and the rest of them. Now they have so many variants that they have, okay? It's primarily used for general purpose coding and creative writing. Then we have a cloud that is from Amazon. It uses, it's safety focused, and then a long document analysis. It has that capacity to be able to analyze a long document. And then you have Palm 2, that's from Google. It's multilingual task and scientific reasoning. Then you have Meta AI, like the one you have embedded into your WhatsApp, okay? You have that embedded into your WhatsApp. Now Meta AI, that one used LLAMA, okay? It's open source and research applications. Then you have BARD from Google also, web connected real-time information. You have DeepSeek. DeepSeek is from China, and then it's free, completely open source, and is considered as one of the major rival to ChatGPT. Okay, then you have the Copilots. Okay, Copilot is embedded into GitHub. If you don't know anything about GitHub, there's need for you to know so much about GitHub. And lastly, we have the QN, that is from Alibaba, and then that is multimodal in nature. Now, each and every one of these, they have their peculiarity, okay? And they have capability of what they can do. What you can do sometimes is, when you have any task to achieve, you can try and lay your hand with the same prompts. Try and lay your hand on one or two or three of these models and see what the performance of each and every one of them will be. Because definitely they don't perform the same way, okay? Some have each and every one of them, they have their area of strength, okay? And so by the time you try your prompts on one or two or three, definitely you will come out with the best outputs. Now, what are the areas that requires enhancement by AI? Okay, we can actually enhance our programming syntax, the explanation, by using AI. We can generate code, and we can also refactor our code. We can do documentation, we can do testing with AI. So these are just few of them I can mention. Now, let's talk about libraries. Jeffrey mentioned that libraries, Python is becoming the most popular, or one of the most popular programming language in the world now because of enormous libraries that are available. So what are libraries? When we talk about libraries, you can just view libraries like a program or an application within that domain, okay? A typical example is that a typical library will be a function that can solve square root of any number. Okay, so we have so many of them. If you go to GitHub and you search for maybe any Python library, I believe you will see a number of them coming out, okay? I've just listed a few ones here, okay? We have the NumPy, Matplot, SciPy, Putty. I think all these ones were used by Jeffrey in the course of his training for us, okay? I want to mention some other ones. We have QMSolve. That is a Python library, okay? There is a repository for it in GitHub that you can actually see some of the examples, ditto to all other ones that we have on the screen, okay? So there's a repository for it in GitHub for you to actually know to what extent it can do. Like for instance, the QMSolve has the capability of solving and visualizing Schrodinger equation for quantum mechanics simulation. We have QUIM. This one has a capacity for quantum information and many body calculation, including tensor networks. You have ATIC. This one is leading edge control system for quantum information experiments. You have Tokito, research library for quantum information theory and optimization. You have the Walrus, is for Gaussian boson sampling and related quantum computation. I'm not saying I've used all this library. No. I wanted to just show you that there are enormous ones that you can explore. And once you identify one that is within the domain of research you want to do, or that stimulates your interest, with the help of right prompting engineering with AI, you can actually delve into it and actually carry out your research, okay? We have a quantum Python lecture. These are basically lectures on Python, though quite old, but I believe it's still very relevant. We have QNet, computer algebra package for quantum mechanics and photonic quantum networks. You have computational physics. This one is just giving some lecture notes too. We have renormalizer, quantum dynamics package based on tensor network states. And we have the PySKTB, scientific Python package for solving Slater-Coaster type binding topological Hamiltonians. Okay, so these are libraries. These are not just exhaustive. You can search for more. Even from prompting, you can ask AI, give me the list of libraries available for research in a particular area, and it will tell you what and what they can do. Now, why use Python for physics? Number one, widely supported scientific library, visualization capability, ease of use and community support, and easily integrate with AI tools. Now, I want to just to look at a typical example, modeling freefall, okay? Now, the prompts I gave is simulate free fall under gravity for 5 seconds with time step of 0.1 seconds. Okay, I've given specific, okay, free fall under gravity, 5 seconds, and time step of what? 0.1 seconds. So I already know the number of steps we have. Okay, if I have 5 seconds and I'm going at 0.1 seconds, 5 divided by 0.1. So that gives the number of steps that I'm expecting at the end of the day. And that's exactly what we have in this code. I didn't have to write this code, okay? With that prompt, AI can give me that. And when that is done, I have this graph generated as a free fall simulation, velocity and time. Of course, they are constant. You have a straight line graph passing through the origin. This is the equation we're looking at. If you look at this equation is talking about, if you compare this one with the equation of a linear graph, y is equal to mx plus c. Of course, your c-intercept is equal to 0 in this case. And so by implication, we are expecting to have what? A straight line graph that will pass through the origin since the intercept is what? Is equal to 0. Okay, so that is what we have just simulated in that place. What are we doing actually in that programming? We are varying this time, calculating t, knowing g, and then we start with 0.1 seconds. We compute v, we get that v. Going to the next one, we change it to 0.2 because we are moving the step of what? 0.1. So 0.1 plus 0.1 will give us 0.2. Okay, so we calculate the next step. So that will give us our V2. Then we get that. Then we go to 0.3 up to the time we get to what? 5 seconds. And if you look at the graph we have, you can see it stop at 5 seconds where the simulation end, starting from what? 0. Okay, so that's exactly what this code has done. I didn't have to write any code. Okay, I already know how to run Python programming, so I didn't have to do it manually. Okay, then going again, we also look at a typical example of an harmonic oscillator, okay? And the prompt here is model simple harmonic motion using Hooke's law, okay? This time around, it's using a library called SciPy, okay? Scientific Python, that's SciPy, okay? And so from that place, we are importing a sub IVP, okay? So from here, you have this also, and this gives me this result. This is the equation that we are dealing with in this case, okay? The simple harmonic oscillator follows a simple equation of motion, okay? Where acceleration is proportional to the displacement, but this time around in the opposite direction. That's why we have this minus sign, okay? The Python code is used to implement this within the domain of X ranging between 1 and 0, okay? And that is what is done there. Then again, we can look at quantum particle in a box. We can say plot wave function of a particle in a 1D infinite potential way, okay? And the code can also be generated the same way. And then this is the output of what I also have from this. And this is the equation that is also being dealt with in this case, okay? Now, effective use of AI. How do we use it effectively, or what benefit are we gaining, okay? Now, we can use AI to speed up iterations and testing of various ideas. As a researcher, as an academic, so many things flow through your mind that you would like to experiment. So many things comes through your mind that you would like to experiment, okay? And so AI gives you that leverage, okay? This time around, you can actually explore whatever idea that comes to your mind, okay? That is the beauty of it. Then always place, this one comes with emphasis, always verify output with known theory. All large language models admit that they are not 100% correct, that sometimes they can generate erroneous, wrong results, okay? And that is why the human intelligence is very, very important at this stage, okay? Now, use code as a learning guide, not blindly. Use code as a learning guide and not blindly, okay? And so if you look at where we are today, we have gone through the basics of Python for 3 good months. Going through the basics before we graduate. We could have started and said, let's start AI to begin to learn Python programming. No, it doesn't work that way. You need to understand the basic rudiments before you can use AI to enhance your capacity, okay? It's meant to enhance your productivity, okay? It's not a replacement for you. So many of the journals, like Elsevier and the rest of them, of course, they are not guiding against, they are not working against the use of AI in any way. No, you can use it. But we're talking about ethical usage of AI, that you take responsibility for anything that is being done. So AI is just there to guide, to help, and to speed up your work. But it's not taking over your job to ensure whatever it has given you is subjected to integrity tests. Okay? Then the workflow of AI is just like this for best practice. Number one, it helps you to accelerate whatever you are doing, rapid integration or iterations of whatever you're doing. Then you can also use to validate. You can compare your results, okay? Then it can also be functionally helpful to learn. It can help you to learn and understand the logic behind whatever you are doing. You can also use it to refine, add domain knowledge to whatever you are doing. And lastly, it can also help to create critical thinking domain for you. Okay? Critical thinking. So by the time you go through this cycle, coming back again, you discover that you are moving faster than you could have done ordinarily. Now, what are the common mistakes to avoid in prompting engineering? Number one, using a vague or broad prompt can be a mistake that will not give the right outputs. Number two, assuming AI output is always correct will be another mistake. Okay, that assumption is a mistake. It can never fly. And then the number three is failure to test or visualize results that you are getting from it. There's for you to visualize and test whatever results you are getting from the AI. In summary, we have actually looked at prompting engineering being a powerful tool that can enhance our Python skills and our physics skills. And then we have also established that effective prompting will lead to better coding experience, will provide better insights, and can give us a leverage in simulations. It can also help us to enhance our productivity. AI can support learning, research, modeling, creativity, and it can also enhance our productivity as well as our capacity. And so, on this note, I want to say a big thank you for your attention. And I believe at this point in time, we can take one or two questions or comments, and thereafter, we go to hands-on experience and see what we can actually do. So questions or comments? Questions, comments? Comments, questions?
Thank you very much, Prof, for
My
the
pleasure.
impactful session. My name is Elvis George.
Thank you, my brother.
I am a teacher of physics, high school.
Oh, you're most welcome. From which part of the, where are you speaking from?
I'm presently in Abuja, Nigeria.
Abuja. Okay. You're most welcome.
Yes, sir. I have two questions, Prof.
Okay, go ahead, please.
My first question is, it is very serious now, those of us in the secondary school, that when we give our students assignments to do, they just quickly run home and go and load the questions into ChatGPT and bring the output they get to us. And it is seriously affecting their learning curve. How best can we help in preaching the gospel of the ethical use of AI, as well as how can we stand between the abuse of AI and children also learning at the same time, especially now that they are still in their formative stages? Then my second question is with respect to publications. I am not yet a researcher, but I have a dream of being one in the nearest future. And just at the time that I'm about to start my career, AI has become very available and very common. How do I use AI ethically without diving into plagiarism? Thank you very much, Prof.
You're most welcome. Thank you. Okay, let me quickly respond to that question. Now, talking about your secondary school students using AI to answer questions, it's not a problem. We refer students born in this age. I think what's the classification of this man? He classified it that children born after, is it 85 or so, or 90? I can't remember the year now, that they are considered as digital natives, while those born before maybe 90s are considered as digital migrants. Now, who are digital migrants? Those who were born before this modernization of this digital age, okay? They came to meet, or rather, the digitization, the advancement in technology came to meet them, unlike those that were born into it. You know what I mean? If a child is born today, right from the time that child is in the hospital bed, the child is already interacting with the digital world, isn't it? Even in some other age, as the woman is delivering the baby, you already see that they are beaming it live. So that child is a digital native, and so you can't separate them from technology. And the point is this: the onus lies on those of us who are educators to ensure we maintain a balance for these students. For instance, as a teacher, you are giving your secondary school student an assignment to do. You can't really stop them from using AI. No, it's not a problem. But rather than for you to give your student an assignment and ask them to type and bring, tell them it must be handwritten. I do it even for the student I teach at PhD level now. Are you getting me now? We can't stop the usage of AI. But the idea is this: rather than for you to just generate content from AI, copy and paste and edit and make it suitable and give it to me, I want it handwritten. When you have finished handwritten it, then scan it and send it to me. You understand it now? In the course of you writing whatever you have generated, you have gone through whatever you have generated. I don't know if you get that. So whether you like it or not,
Yes,
when your students are given assignments and you ensure that they write when they are submitting it, in the course of writing it, they are already learning it, okay? And beyond such measures too, there is need for us to also consciously create awareness in them. Like for my undergraduate students, I tell them something whenever they come to university early, once they resume, new test of students. I tell them, you are born into technology, there's no doubt about it. However, technology has come to stay, but this technology you have talking about your phone, your computer, and the rest of it can either be your master or your slave. Is that okay? If you allow this technology to become your master, then you become a slave to it. And I will explain to them, who is a slave? The slave is the one that is being controlled by the master. So whenever your phone is the one controlling you, then you have become a slave to it. And there's need for you to actually ensure you are not a slave. Rather, you should be a master over the technology that you have. Okay? And so by that education alone, a number of students are able to come to the consciousness of how best they need to manage the usage of their technology. But that doesn't rule out the fact that so many students are still engrossed in that mess. Okay? Because some of them, they will fail at the end of the semester, and I ask them the question, what can you say about your phone usage? And they will talk about how guilty they have been in the usage of their phone. Are you getting my point? So there is need for us to continue to educate them and put some measures in place to be able to ensure that some learning takes place whenever they are using that technology. That is that. And then on your second question, talking about research and publications, of course, all the publishers, they recognize that AI has come to stay. Okay? Maybe I will even be showing you some of the some other AI tools that are available for usage as well. You understand it now? They are there to stay. What we are all clamoring for, of course, AI ethics is also another evolving field that discussion are still going on. There has not been this thing. But so many journals have come up with basic policy about the usage of AI. For instance, Elsevier, I was reading some of their policy. They are not stopping you from using AI in your content. They don't have any problem with that. Are you getting me now? But what they're saying is you take absolute responsibility for whatever content you have generated. And ethically, we don't also allow copy and paste. We don't encourage it. Let me not say we don't allow. You understand now? We don't encourage it. Okay? For instance, a paper was retrieved from Elsevier some moments ago. What happened in that paper? The author was just copying and pasting. And you know, when ChatGPT gives you content, you will have some background to what is giving you. See the code that you have asked for below, something like that. And everything was seen in that publication. It went through peer review and it was published before that paper was brought down. And so in such a situation, you can see that that person has not ethically used AI. He didn't take responsibility. He didn't even read through whatever you have generated. So those are the aspects that has to be looked into. But to say you cannot use AI, no. You can use it and use it ethically to enhance your capacity and improve your productivity. That is why it has come. Okay, there are so many advanced AI that are specific to researcher. We have connected paper, we have SciSpace. Those ones can help you awesomely with your literature review. Instead of going through so many routes to do your literature review, it will give you some of the information that you need in no distant time. If you have time, we may be able to look at some of those things, maybe practically before the end of today. I don't know if I've been able to answer your question,
Yes,
Mr. John.
Prof. Thank you so much.
Okay, my pleasure. Any other question or comment, please? Any other question or comments?
Yes, Prof.
Okay, you're welcome, sir.
Yeah, good morning and good morning all.
Good morning.
Yeah, Prof, I so much appreciate your lecture and the way you just responded to those questions. Uh, just like you just said, just like the other Mr. Ivis also asked, I have this issue with my students too. When you give them assignment, they will tell you, we'll go to Google. Now, I try as much as possible to ensure that they go to the library, at least get textbooks. When they get textbooks, they write and submit. But sometimes from the explanation or the way you responded to that question, it has actually given me a clear view on how to, deal with them in situation like that. Sometimes they think I'm suffering them. I'm giving them headache by ensuring that they go to library, write those things, and then bring it back to class. And some of them will like, sir, but we can get all this thing from Google and submit. I will say, no, go to library and get something done. But from this understanding now, they are digital native. We must not rule that. We must not rule that out. But it's also from your response to, we just have to look for a way by ourselves to guide them in ensuring that whatever they are copying from any source, that they also have the proper understanding of what they are writing. I think it's a good way to go. I really appreciate that. Thank you so much. Because sometimes some of us, we do some of these things without even knowing fully well of what we are doing to them. They're like, sir, you are suffering us. I would say, no, I'm not. So just go to library, write it out. But just do it as if. But now I have the full, better understanding of whatever I am doing with them. It's also going to help me too as a researcher and whatever I am also doing. I really appreciate that. Thank you so much.
That's good. Let me just put a quick addition. I know you work in higher institution, okay? At that level, make your students to include scientific reference in whatever they are writing and submitting to you. They can go online. Are you getting me now? This time around, for instance, you are giving them an assignment to do. Let them learn how to go and get journal article and reference it in any assignment they're giving to you. Okay? At that point in time, they have just gone beyond asking Google. They have gone just beyond asking ChatGPT. Are you getting me now? They have gone to the extent of involving scientific input in whatever they are doing. Okay? For instance, you have given them just simple example of go and define physics. Okay? Tell them you don't just want definition of physics. Okay? They should be able to tell you what is the reference where they are picking it from. With textbook, define physics the way you are giving it to me. So let them begin to include references in whatever work they are doing. That gives credence and then credibility to whatever they are submitting to you, not just any random submission on the internet. Okay? So referencing can actually also add value to any write-up, academic write-up. Thank you.
Thank you so much.
Any other question or comments? Question or comments? Okay. If there are no further question or comments, now, can we now go to, let me stop sharing. I believe most of us, or all of us, we are on our computer. So let me advise us to all go to our browser. Let's go to our browser. Just open any browser and let's start from there. And let me also find out how many of us, or do I assume that all of us, we have Anaconda installed on our system? I know for majority of us in the course of the training, we were running our codes online. So now, do we all have Anaconda running on our system? Please, can you confirm to me by any means, maybe through chats or through whatever? Okay, so Gloria has Anaconda running. Any other person again? Please, just confirm, please, so that let's be sure we're on the same page. I know I'm saying this, it will really go a long way for you to continue from where we're doing here. Okay, so Miss Ivy's have it, awesome. Okay, who else again? Mr. Dewopo, Mr. Jonathan, Mr. Leonard, please, can you respond if you have it running? Mr. Ayindeshu, please kindly confirm if you have it. It's very important that we are able to have this. Oh, Mr. Jonathan, you're just doing that. Have you been able to, can you unmute yourself and speak to us? So let's know where you are, because this stage is very critical, so that once you are able to start it on your own there, it means a lot to you going forward. Mr. Jonathan, can you unmute yourself and speak?
Yes, I just downloaded. Yes,
you downloaded it.
Yes, I just downloaded it.
Quickly install.
I'm trying to see. Yes, it has even installed.
Okay, if it has installed, let me just hold on there. I will show you how to launch it. Okay, I will show you how to launch it if it's installed fully. Just hold on. Any other person again trying to install? Okay, if there are no other person trying to install, so we need to quickly move on. So I want to first of all launch Anaconda from my, I want to launch a Jupyter Notebook. That is my Python platform. I will launch it from my, okay, let me share the whole of my screen for us to see what I'm doing here. So I'm sharing my entire screen. Okay. We can see my entire screen, right?
Yes, Prof.
Okay, great.
Yes.
Okay, good. Now, my start menu, click your start menu and type Anaconda. If you have truly installed Anaconda, you should see Anaconda prompts like you are seeing on my screen. Can you see it?
Yes, Prof.
Okay, great. So click it and it will give you Anaconda prompts. Now, let me quickly mention, by default, it will bring you to your username directory. That is where it will bring you to by default, okay? Where it's bringing you to, if you go to my computer, this is where it's bringing you to your C. You can see you have users, and after users, SOLAY. So this is the location where you are, okay? This is the location where you are on that prompt. I don't know if I'm communicating. This is the location where you are on that prompt. So Control L will show you the full URL if you are browsing it, okay? That is where you are on the prompt. Now, if you choose to run your Jupyter Lab command here, okay? What will happen is all files that will be created will be stored in this location. So whenever you need to access the graph you have plotted or whatever you have plotted, it will be in this place, okay? Which I don't think, it might not be too neat, okay? So I will advise that you use CD dots, step back once, okay? CD dots, that is you are changing directory, backward once, okay? You can see what has happened on my screen. Then you do it one more time, and then you come back here. CD ... So this time around, you are directly on your drive C. You are directly on your drive C. So for you, Mr. Jonathan, you can simply type this mkdir, make a new directory, okay?
Okay,
It's
sir.
like you're creating a folder and call it a name, say my Python or whatever name you want to give it, my Python, okay? So give it a name.
Okay.
And once you are able to, I'm not going to create that folder in my own case. I don't need it, okay? So once you are able to create that, whatever name you are giving it, then next, change directory to it, then CD and type the name of that folder you have created, okay? Have you done that?
Sorry, I'm trying to make that directory.
Okay, okay.
mkdir.
Yes, mkdir. Then give the name you want to give to that directory, okay? Now, let me also mention this for the purpose of, for the benefit of every one of us. Whenever you need to install any library, either using pipe or conda to install, you also need to also do it from this Anaconda prompts, okay? You need to do it from the Anaconda prompt. For instance, I want to install maybe QTIP, okay? It will be pipe install QTIP, okay? On this terminal. That is how the installation is done, okay?
Oh, please, I'm having a little issue.
What's the issue you're having?
I'm changing the directory. I think I'm
Yes.
going to type mkdir.
Yes. Can I type it again? You are creating directory.
Yes.
mkdir space. And the name you want to give to the directory you are creating.
Okay.
mkdir
dir
space.
space. Okay.
Yes.
My.
So are you done?
Yes.
Okay.
My Python. Okay.
So
So it's taking
then
me down
CD.
to the C
Yes.
now.
Then CD. CD again. Name of that same directory.
Okay.
So by implication, if you have done that one, it should have taken you to that folder, isn't it?
Yes. Yes. Take me to that folder.
Good. So that folder is located directly inside your drive C. Whenever you want to
C.
access it through my computer, you can access it there. Okay.
Okay.
So stay in
Okay.
that place. That is where you will work today. In my own case, I have my drive D. That is where I want to work. So I've changed to my drive D. And then I have this location where some of the work I want to do. I think, okay, let me see. 2025. See, I think April. Okay. So DIR can give me the list of what I have in that place. Okay. So I'm already in the folder. Okay, no, I may not even need to do this. Let me go back. I think it's smarter for me to stay in the root directory. Okay. Then type Jupyter Lab. Jupyter, JUPYTER space lab to launch your Jupyter Lab. Okay. Have you been able to do that?
Is it from the folder created?
No, from your terminal. Yes, inside that folder. Yes.
Inside
Jupyter.
that folder. Okay.
Yes.
Okay.
Jupyter Lab.
Done, Prof.
Yeah.
Okay. It's done.
Are you there?
Yes, I'm there.
Yes, Prof.
Okay, so go ahead and launch that. So that will automatically open for you. The Jupyter Lab will be open for you in your default browser. In this case, my own default browser is Edge. Okay, so that's what I have here. So this is Jupyter Lab. And by the left side here, you can see the location. So you can actually navigate around. Okay. See the location where I am. So coming back here directly, I can navigate around 2025 and come inside April. This is where some of the code that I am working with. Okay. Now, let's now go to, okay, we can use the same browser. Okay. I'm using the same browser. I hope I have an account to access this thing here. So let's start with ChatGPT. Go to ChatGPT login. I'm not sure. I think I'll use another browser since all my accounts are shared. Let me use this. So I have this. I have so many of them open down. Okay. So I have this. This is the URL for that. You can just search any of the name online. For instance, you can say Copilot. So if you search it, it will bring it up. Then this is cloud. So I have about how many of them open down here. So I have Copilot, I have a cloud, I have a ChatGPT. Let it go to a new chart. Then I have this, okay? Then I have this. So I have about 5 of them open down. Now, let me give every one of us tasks to do. Just think of anything that comes to your mind for ChatGPT to give you a code on. Just think of anything that comes to your mind and ensure there's a visualization included there. Just think of anything. Think of somebody has done out. There are very few of us here. So, can you quickly think of something? Prof. Okay, I'm just registering my, okay, good. Now, can you think of something you want to do? You want to share something that comes to your mind that we should do. I have a number of things that we can do, but I think we should begin to simulate our own thinking. I believe each and every one of us, we have what is in our mind, maybe a research you're trying to do. Can you think of something along that line? And let's start from there, okay? And let's see what we can achieve. Just something that comes to your mind. Yes. You can mute yourself and talk to me if you have anything. Or does anybody have any suggestion of what you think we should do? Then I will tell us the prompts for us to start with. Just think of any problem or anything you think we should do. And we'll begin to prompt. Yes, anybody? Okay, do I call us then? Gloria?
Does it have to be like physics or maybe what the research you're working on? Because if it's the research, I can say something about my research and see if we can work
Okay,
on
talk
that.
about your, yes, talk about your research.
Maybe we can simulate maybe the physical properties of inorganic perovskites, and then maybe rubidium.
Physical properties of inorganic.
Sorry, mechanical. Sorry, let's just use mechanical properties. Yeah,
Okay, mechanical properties
yeah.
of inorganic perovskites, right?
Perovskite. Yeah.
Okay. Now, what are we looking at? The theory, the model,
Maybe the
give
model.
more detail.
Maybe
Yes.
yeah. So, okay. Maybe we can try this structure more so for tetragonal phase, like maybe
Okay.
rubidium,
Now,
germanium, iodine.
let's assume you don't even have maybe details of that. Okay.
Yeah, yeah,
But we have a problem we want to do. We have a problem we want to address, right?
yeah.
How to start? You can start with how do I simulate mechanical property of inorganic perovskites using Python. Okay?
Yeah.
You are starting from the basic way. Okay? So, can we try that? Can we try that? And tell me what you are having. You can try it on different prompts. Okay? If you have opened a number of this. Okay? Can we try it and tell me what you are getting? Or do I paste it in chat? Would that be faster for us to copy and paste? Okay. I've pasted it in chat so we can just copy and paste. So let's try that. If it works. Yes, how many persons have been able to do that?
I have, Prof.
Okay. Can you share your screen with us? Share
Okay,
your
Prof.
screen with us and let's see what you have.
All right.
Yeah, share your screen with us and let's see what you have.
Sorry, just a minute, I'm on it.
Okay.
I'm trying to share. Oh.
Okay, this you're sharing. Okay, great. Okay. How do I? Okay, got it. You are asking how to simulate like elastic constant bulk modulus. Yes, of inorganic material using Python. Yes, that's an awesome project. There's a roadmap. Okay. First principle. Okay. Using DFT. Then you have empirical potential. Wait, let's go to that empirical potential. Go up a little. Empirical potential, molecular dynamics are faster but less accurate. Okay, so go ahead. Then use suitable Python library. You have atomic simulation environment, ASC, then PyMargen, yes. Then you have atomic simulation code, quantum espresso, VASP, GPAL, okay, yes, go down. Okay, now, basic step, build perovskites. Let's see what it's doing. It's already giving you code. Let's see the code is giving you. Okay, in this case, there will be need for you to go and install what? Which library do you need to install in this first place if you are going to work with this code?
PyMargen.
Huh? Okay, PyMargen, okay? PyMargen, you need to have that, okay? Go down. Then perform elastic tensor calculation. So you have ASC plus this. You need to also do what? Go and install your what? ASE. Okay? Are you there? Hello? Are you with me?
Yes, Prof.
Good. Then scroll down. Go down, go down. Okay. Then mechanical property. Go down, yes. Then optionally, you can automate with what? AI complex workflow, or automate workflow using PyMargen and Fireworks. Okay. If you want to be fancy. Okay. Go down. Now, you can see what that's giving you now. Do you understand? So if you run those two code snippets you have up there, you would have been able to get to this second stage, okay? And from there, you can go ahead and then work manually to get your results. Otherwise, you need to go and work with IDA, or you will need to use Automate to be able to automate your process, okay? So going through that will require you to ensure you install those libraries that are needed before you can be able to do that, okay? And sometimes working on window, you have limitation. Okay, go up. Let me show you something. Working on, go up, go up. Now, go up, go up. Go up. Go up. Good. Oh no, down a little. Go up a little, a little. No, 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 no. The other way around. A little more, 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 a little more. It's okay. Now, look at what we have in this state. You need atomic simulation code like quantum espresso. You need a VASP, and you need this. Okay. These are all ab initio codes. Okay. You need to have them installed before you will be able to carry out this calculation. You getting me now? Of course, we don't have a quantum espresso that is effectively running on Windows for now, even though we have some that can run through third party. Is that okay? And so if you want to really go ahead and do this calculation, what do you need to do? You might need to switch to the virtual environment we created, virtual OS that we created the other time. Is that okay? And go and install your Python notebook there for you to be able to work. I don't know if I'm communicating. Okay?
Yes, Prof.
Because all the software that you need to be able to achieve this, they are not easily available on Windows platform. And so there may be need for you to migrate to a Linux environment like, what is the name of this that we were using? Quantum Mobile, okay? Quantum Mobile already has all of this installed. It's just a matter of you installing your Jupyter lab there, and you will be good to go to run all of this code. I don't know if I'm communicating.
Yes, Prof.
Awesome. So that is that. Any other person again? So, Gloria.
Yes, Prof.
Okay. I hope you are okay with that explanation.
Yes, that's fine because I already have Quantum Espresso and also I have an both. I also have an Anaconda, so I think I can go and do the comparison
Awesome.
after this. Yes, thank you so much. I
Awesome.
appreciate
Awesome.
it.
Awesome. 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 Okay. So, who else again has any idea of something you have in mind that you want to do? Any other person? Just think of your research. What research are you doing? Let's look at it and explore something, or you are thinking of a problem in your area. Okay, a problem in your area that you felt you want to address. Go into research. Yes. Any other person? Nobody's thinking of anything like that now. No research is in mind. Huh? Okay. Let's still use our prompts. Go and look for a problem. So I will share my own screen again. Okay, can we see my screen? Can we see
Yes,
my
Prof.
screen? Okay,
Yes.
great. Now, I want to know what are the prevailing problems in Kenya that can be addressed using physics concepts simulation. So, I've given a prompt. I'm looking for a research to do. I'm looking for a problem to solve. Because the essence of research and our work in the research world is to solve societal problem, okay? And we are physics by heart, so many of us, okay? So on that note, what are the problems, okay? So I'm gonna come down to our domain, Kenya, for instance, okay? Problem, many rural areas still lack reliable electricity. So we can have simulation solutions like simulating solar energy harvesting optimizing solar panel placement using optics and thermodynamics. We can simulate wind energy potential across different terrain using fluid dynamics. Battery storage performance under Kenya climate condition. Okay, that is a problem that can be addressed. Then you have other ones, water resources management, water scarcity and inefficiency. So we can begin to model groundwater flow using fluid dynamics and hydrology physics, simulating rain harvesting system for urban and rural settings, and so on and so forth. Infrastructure development, healthcare, medical physics, agricultural productivity, so on and so forth. So looking at just this prompt, can we pick one or two? Or better still, I should leave it open for, how many of us are here now? Okay, Mr. Jonathan, can you pick one from this and begin to tell us what you can achieve with it? Pick any of the problem.
Okay.
From solar, which one do you want to pick?
Simulating solar energy harvesting.
Okay, see what I will do. I'm copying everything and pasting it in our charts. Okay. What we are doing here, do you know it can actually be done and follow up to a publication level, as small as it is. Because what is the essence of publication is to address societal problem using novel ideas and then making it into the public. And what we are doing at the moment now, is that we have picked a particular country and we are trying to look at the specific problem affecting that area. And we want to use our physics concepts to actually solve that problem. That's what we're trying to do. I'm pasting it there. Each and every one of us should go ahead and pick one. So, Mr. Jonathan, you are picking one from number one. Who else? Mr. Ayinde, are you there? Mr. Dewopo, do we have you here? I'm not sure the two of them are close to their device. Okay. So the two of them are not close to their device. So, Mr. George, which one are you picking? You can pick one from number two, or tell me the one you are interested in. Let me show it on the screen. You already have it on the chart, so you can go and copy it there. So which of them will you like to? Let's start from number two. Yeah. So Mr. George.
I'll pick number two. Yes, I'll pick number two, Prof.
So which of them? You know, I have three instances under number two. So okay, which of them?
Groundwater flow using fluid mechanics and hydrology physics.
Great. So pick that and I will tell us how we'll proceed. Okay. Then what next again? Okay, I have Gloria there, right?
Yes. Yes, yeah. But you haven't pasted that in the chat.
Which? No, I think I have all of them in the charts, I guess.
Oh,
yes, I have all of them in the charts. Okay, don't worry. Which one are you thinking of picking? Let me, I can paste that specific one for you. We have healthcare. Look at it. We have healthcare. We have agriculture. Then we have traffic and urban. Then we have climate change.
Climate change.
Okay, awesome. So which one would you like to pick out of in the climate change?
Regional climate modeling using thermodynamics.
Okay, great. Now, I'm going to paste that also for you. Now,
Prof, sorry. Sorry,
yes,
Prof.
go ahead.
Go ahead.
I didn't get that. Okay, the file is too large. Yes, I've just pasted the three. The file is too large for me to paste all of them. Is that okay?
Yes, Prof.
The file is too large for me to paste all of them. Yeah. So, but I think I will still save it for us to I'll try and save it for us to just maybe look at. So maybe I'll paste it on our WhatsApp group. I think WhatsApp should be able to take it. So we can make reference to it on our WhatsApp group. So I pasted it on our WhatsApp group. Now, let's quickly go ahead and see how do we proceed from here. I think that is the next thing, right? Okay. Hello, are you there?
Yes, Prof.
Okay. Now,
Yes.
how do we prompt to be able to get direction for what we are doing? Okay, I think I should go and choose one for myself as well, so that I use my own as a reference point. Okay, planting season, drone flights. Okay, let me pick healthcare. Okay, now the best way to start is for us to first of all understand the theoretical concepts behind what we want to do. Okay, and so having your topic pasted, let me just use this. I need the theoretical concepts to model this, with relevant, okay? I need the theoretical concepts with relevant mathematical or with relevant equations to model this. Model this. Now, this, column. I don't know if you are seeing what I'm doing. Theoretical. Are you seeing my own prompts? I'll paste it in the chat for you to see what I'm doing. So I want to know the theory behind what I want to do. Okay, I've pasted mine with the topic I've chosen out of all the lists that we have. Okay, so I need the theoretical concepts with relevant equations to model this. Okay, so I want to know the theory behind it, what I want to do, not just the code. Are we there?
Yes, Prof.
Okay, so if you have it, you can go ahead. Definitely we'll be having different things. So we can then begin to share our screen to discuss what we have. Okay, so in my own case, I have fundamental equations talking about attenuation of radiation through tissue. I have my dose also there, okay? Now, I have photon fluency decay, then the modeling step, okay? Then I have the extra concept for more realistic simulation, okay? Are we there?
Yes.
Yeah, okay, right? Now, if you look at my last page, if you want, I can help you build a simple Python program that simulate dose distribution for a given setup, allow you to change parameters, e.g. tumor depth, energy, and visualize dose curve with matplot library. Will you like me to draft the Python code for you next? I can simply say yes. Okay? Are we together?
Yes, Prof.
If I simply say yes, I have this. So what does this code do? Define tissue property and beam energy, calculate how photon influences and absorb dose decay with depth. Then plots depth dose curve, shows how dose falls off deeper into the body. So you should see a smooth exponential decay of dose. How can you expand this? You can add a build-up region, simulate secondary electron, include tissue, simulate beam, and so on and so forth. Okay? Now, let's start with this simple code we have already. I'll copy this, and I'll simply go to the browser where I have my Python running. So I will create a new one. So, Mr. Jonathan, I hope you are able to create new Python notebook. So I can rename this file. I call it.
Can you come again, please?
Yes, go back to your browser where you have your Anaconda. I'm sorry, Jupyter Lab running. Are you there? Are you there?
I'm not there, please.
Okay. Will you share your screen so that let's know where you are? Would you like to share your screen so that we know exactly where you are?
Okay. Share.
Yes. No. Mr. Jonathan. Now,
Yes, Prof.
This is your Python environment where you are doing your coding. Are you with me?
Okay, Prof.
Now, what you are trying to paste here is not supposed to be a code that you're supposed to come and paste in this place. So copy this and go back to ChatGPT. Copy this or cut it from here. Cut it.
Okay.
Cut. Yes.
Okay.
Then go to any tab. Go to another tab on your browser.
Okay. I can share this now.
Just don't worry. Just click the next tab as you're trying to do. Oh,
okay.
Just share your screen fully so that we can just follow up with you quickly. Our time is fast running out.
Yeah, Prof. What this I should do now?
Share your screen. We're not seeing your screen again.
Okay, which one should I share?
Share the old browser you were sharing with us. That same browser you shared with us now. Share it.
Okay.
Yes. You will just be switching between tabs. That's what you will just be doing. Okay, just click the next tab. The next tab up.
Next tab.
Yes, you have multiple tabs that are open for you. Up. Go towards right up.
Okay.
Good. Just no, this one is okay. Don't worry. Just go up. Wait now. Go to that address bar. Just go to the address of one of them. Just go to the address up and type ChatGPT in the address bar. So click ChatGPT. Click ChatGPT down.
Yeah, go and sit down.
Take it easy with the children. No. They are in their father's house.
So I can click on this now.
Yes, click on that. Click on that. Click on ChatGPT and open it, then sign up. So that is where you'll be doing your prompting. You have not logged in. Go and click sign up there to the right. Go sign up.
Okay.
Go and sign up. Good. So once you finish signing up, that is where you'll be doing your prompting. That is where the code will come out for you. So continue with your Gmail. Click continue with Gmail. No. Down. Click continue with Gmail.
Okay.
Yes. Continue with Gmail and just authenticate. Then you are good to go. Okay. Then choose your email up there. Then click continue. Okay, so you need to put your detail. So once you're able to do that one, you'll be able to chat. Okay. So now, any other person again, let me know what you are doing at the moment. Have you been able to prompt and have you been able to get a solution? Will you also like to share your screen with us, please? Let's know what you've been able to achieve. Please. It's really important Even if it's just 3 or 4 that can get it, I'm fulfilled for today, honestly. Believe me sincerely. And we are not doesn't really matter. If it's just one person or just 3 of us, if you are able to confirm that we've been able to at least get something meaningful, that's worth my time. Okay? Good.
Yeah, Prof, you will need
I
to
need
stop
to
sharing
answer
his
some
screen.
relevant question. So your own topic now. Go copy from the chat and put it there, Mr. Jonathan. Yes.
Yes, sir.
Mr. George, would you like to share your screen
Yeah.
with us too?
Okay, Prof.
Okay, please go ahead. Then Gloria, what are you doing at the moment? How have you been able to go?
Yes, I've been able to from it. So I have also I have the suggestion that it gave me.
Okay. Let's say your okay, let's say that. Yes. Good. Okay, so you have your theoretical concepts already established. Okay. Good. Then go down.
Okay, it's from here.
Okay. You have the code already.
No, this is where I typed these are the theoretical concepts.
Okay, okay. Go down, go to the last line. Yes, that's beautiful. Yes, go down. In simple. Now, would you like me next to show you how these equations are discretized? For example, with final differential, so you can actually simulate. Yes, just click yes. So you should go ahead and discretize it. Okay, step 1, start with groundwater. Okay. Now, you also know that you can get all this that you are having here, you can get it as a lattice code, okay? You can get it as a lattice code and then have it as an editable lattice document, okay? Or lattice file. Okay, so here is the full Python code, okay? So you can copy your code, but your code, okay, your code is complete. So copy your code and see what this code does. Scroll down, let's see what your code does. Okay, divide the aquiver into 10 cells, then a set of another different equation, apply fixed head at boundaries, solve matrix equation for head distributions, plot head versus distance. Okay, now, your prompting can continue from here. Okay, copy that code and run it first. Let's start with that before you do another prompting. Just copy. You can see copy showing up here. You can just no. You may not need to select. Yes, copy. Great. Good. Just click copy. Yes, you have it already. Then paste and then run it. Let's see what we have.
So, which of the
Yes,
versions
click new. The
Python?
first one notebook. The first one is notebook. So
Okay.
it will be saved in the location where you are. It will be saved in location where you are with the name untitled. If you want to change the name, you can right click on that untitled and give it a name. What are you simulating? Right click on it and give it a name.
Okay.
Yes, right click, rename is up there. So what are you simulating? Is it groundwater you're doing? Good. It's okay. That's okay. It doesn't have to be too long. Okay. Sim, it's okay. That's fine. That's fine. Yes. Press enter. Then run your code. Shift enter. Just click within your code. You have this arrow up. That's a play button up to run your code. Or when you are in the code, you can just shift enter from your keyboard. That will run the code. So whichever one you prefer, quickly do that. So your code is run. That's what you have for now. Okay. Now, go back to your prompting. Go back to your prompting. Go back to your prompting. Now, your prompts are these. I want an advanced simulation with 3D. I want an advanced simulation with 3D plots of visualization, or with 3D plots of visualization, as the case may be. Plots is okay. Press enter. It will also give you another code, and it will explain what it's trying to do for you. Okay? Now, while all these are going on, the next prompt I will ask you to do, okay, do this one, to complete this one first. Complete this one first. The code is still being generated. So it's not done yet. Oh, no. The code has not finished generating. Go back there. The code is still generating. See, if you look at the button down, that black button down, it will change.
Yes,
when your code finish generating to something like an audio file. Yeah, that's when it is done. Okay. So your code is done generating. So, and it's also explaining to you what it has done. So you can copy this code. Then paste it. Then run it again. Let's see what it will give you. Okay, that's what it has been able to give you. So now, the question is, you have all of this now. You have the theory, you have the code. Okay? Now, that code you have copied, go back to your browser and go to cloud. C-L-A-U-D-E. C-L-A-U-D-E. Yes. Just search it and then log in there if you have not created an account there. Or that you are doing your ChatGPT, you can also do it elsewhere. Please take note of that. Okay, now let's go back to your ChatGPT. Since this one is loading, you can try that one later. I want us to close at around 12. Go back quickly to your, yes, go back to that place. Yeah. Now, what I want you to do now, request for, just ask that you want, will this guy do it very well? Okay, just say, I want the latest code of the mathematical aspects of the modeling as well as the code. Mathematical aspect of the modeling and the code as a detailed document. As a detailed document. That's a prompt you are giving. I guess you are familiar with the use of lattice code. Go ahead, just press enter.
Prof. Okay.
Don't worry to correct it. Don't worry to correct it.
Okay.
Yes.
Okay.
So just press enter. Now, it will give you a lattice code. Okay. Now, the point is, lattice code, you can go and register on Overleaf. Copy this code, take it to Overleaf online, or you go and download Tech Work and install it on your system for you to be able to run lattice code. Okay? Are we together?
Yes, Prof.
So with this, you'll be able to see the detail of what you have done. Let me allow Gloria to also share what she has done with us. Our time is fast running out. Gloria, can you quickly share what you have done with us briefly? Gloria, are you there? Gloria? Gloria, are you there? Okay, I'm not sure she's close to her sister.
Yes, bro.
Okay.
Sorry. I was trying to share the screen and then I couldn't unmute myself. Sorry.
Okay, that's fine. So go ahead and share your screen, please.
Are you able to see my screen?
Yes, we can see your screen. Great. Okay, so scroll down. Let's see your theoretical concepts.
Well, I think it's from.
Okay. Yes, go
Yeah,
ahead. Go ahead.
here.
Go ahead. Yes.
So
Okay.
let's see.
Okay. Okay, Navier-Stokes equation, yes. The thermodynamics, you're combining the two. Radiation transfer equation, yes. Go ahead. Okay. The mass continuity equation, yes. Moisture equation to vapor, yes. Okay. Okay, go ahead. Go ahead. Go ahead. Yes. Okay. Example, yes. Yes. Go ahead. Yes. You now requested for
That's
code.
the end.
Okay, that's where you stop. Then request for the code.
Yeah, yeah. I request for the code.
Yes, go ahead and request for the code. Look at it. Explain, sketch a conceptual diagram. Look at it. Will you like me next to, okay? No, let us
Yeah.
give you a, no, but diagram is not working too fine. You can do that
The
one
diagram.
later. No, no, leave
Yeah.
that one. I'm not sure the model is responding very well to
Please.
that. Yes, go for the second
Oh,
one. Explain how
okay.
Python can, yes, can be used. Not just explanation. Okay, you have pasted that one. I would have wanted you to, but it's okay. Let it explain.
Okay.
No, no, go ahead.
Oh,
Just let's follow what is going on
okay.
there. Okay, good. It's already giving you the mini climate model. Good.
Yeah.
So it's giving you a simple one. Okay.
Yeah.
Now you can request for advanced one based on what has been done. Are you following me? You can request
Yes.
for advanced one and also go ahead and request for 3D model of your simulation. Okay. There is no
Yeah.
end to what can be done. Okay. There's no
Yeah.
end to what can be done. Let me quickly add this. If we are motivated enough, the topic you have picked is something you can actually follow up to a publication. And if you are willing for us to collaborate on that, we can actually use that one as a platform for us to actually collaborate on it. And let's see how we can turn it to a simple publication, the topic you have just chosen with this. Lastly, I would like to just share with us a platform that I feel is very, very important for us to do literature review. It will really help us. I want to share my own screen right now. Can you see my screen? Can you see my
It's
screen?
coming. Yes.
Okay,
Yes.
great. So
Yes, we
the
can see
site
it.
is SciSpace. Okay. SciSpace. I hope it's here. SciSpace. Okay. This is the website. I'll copy it and paste it on the chat. So we can also try to register. There is 12 o'clock already. I'm conscious of time, but I think let me just beg for 5 minutes so that we can actually put this in proper perspective. Okay, so you have that in the chat. Now, continue with this. I hope I have this. Okay, so what I have here is SciSpace. In SciSpace, you can do a lot. It's a premium platform, but it has a lot of free opportunity for you to be able to do your literature review. And I'm going to show us briefly some of the capability that we can benefit from in this place. Okay, now I can just put a query here. Okay, I'm going to put my own topic that I've chosen. Where is my topic that I chose? I can't lay my hand on mine. So I'll pick the topic of any of you at random. Okay, I think I have mine. So this is my own topic. I guess this is mine. So I'm going to use my topic, right? This is my topic, okay? So once I just paste my topic here, radiation dose simulation for cancer treatments, helping optimize low, I think radiation simulation, cancer, helping. Okay, let me leave it as it is. So just click search. Basically, I didn't do anything. So what site space will do for me is to, okay, it's giving me general insight, but it's not exactly where I need it, really. So I paste it in this place where we have papers. Then I just search. Close this free option I need. So I paste my topic in this site space up where I have papers. And it will go ahead and bring papers related to these articles for me. Okay. So that's what it's trying to load for me. And it will give me a brief background of what I'm trying to do. This is AI generated content, machine learning and simulation speed. So somebody has done something related to this in 2023. So I'm already having literature that can form the basis for my work. Okay. Now, I have that this person used Monte Carlo simulation software. Okay. I can also expand this here. Okay. I have 2013 work. I have 2007 work related to this. I have 1998 work related to this. Okay. Now, coming down, I now have papers. I have about 10 of them. Okay. Now, look at something here. I'm going to expand this. To the right here, let me try to reduce this. You know, I just have the paper and the insight into the paper, just like an basic insight into the paper. I can add all of these columns, but because I'm on a free subscription, I can only add maximum of 5 altogether. Okay, so there are 11 more things I can add here. So I can go ahead and ask what is the objective of each of this paper. It will be generated. I can ask for the research gap each of this paper to be provided. I can look at the problem statements that motivated our research. It can be added. Okay. Then what data sets were used? I can also add it. I said it's maximum of 5 I can have. Okay. Then what method was used? So I've exhausted the option I can do. So, but I can remove anyone at any point in time and add the one I want to add. Okay. So I can minimize. I can delete the insight here. Then I can then go ahead. I'm just zooming my screen to be able to see all the column at once. So then I can add, what was I trying to add? The method used, okay? So I've been able to add 5. It's 5 I can add at a time. Now, if you are on a premium subscription, the output can actually be exported as a CSV or any format. Because I'm a free subscription, I won't be able to export it. However, I always look for a way around it. So what's the way around it? What I do is to copy, and then I will select, and I take it to, it's still generating the content, still going through all the papers, and then bringing out my requests, okay? So I copy all of this, and I take it to Excel, okay? So from Excel, I can look at it and view it and begin to know exactly what to do with what I have, okay? So that is how I use this, and it's really, really helpful. Another thing I would also like to show us is that you can actually go to your library and then upload an existing journal article you have downloaded from any source related to your work you want to do. So you can actually upload that. And once you upload the document here, you can also use this tool to actually check all of the parameters we were looking at just now. You can look at the research gap. You can look at all the detail. You can even chat with individual paper within this space. So it's a good AI tool that can help you in research, and it can really help us to build very fast and quick research library. I also want to believe that so many of us, we use a Mendeley or other referencing supporting a software. You understand? If you have not been using it, we need to, okay? Like if I want to get this reference into my library of either Mendeley or Zotero, as the case may be, all I have to do is to click this paper and open this paper. So, or if I come down to this place, the DOI of this paper is somewhere here. Once you click the DOI of this paper, it takes you to the page of that paper. So from the page of that paper, I can then, it's a Springer paper. So I can copy the citation here. Where is citation? Cite this paper. So I can download this BIB or RIS file, which can be uploaded directly to the library of Zotero or any of the referencing software we're using. So I think it's been 8 minutes past 12. And I think we have had a very awesome interaction today. If you don't mind, what would be your reaction for today's experience? Maybe in the chat. First type how you feel about today, and then what will be your reaction? While I say thank you for your time, it's been an awesome time interacting with each and every one of us. And I believe we can take it off from there and then enhance our capacity through AI prompting engineering. So I'm waiting for some response. Okay, I've seen, I said, wow, that's super helpful, Prof. Thank you, Gloria. That's quite encouraging. Oh, it was really awesome. It was really awesome. Okay, let me screenshot this. Okay. It was really awesome, Prof. God bless you abundantly. Amen. And you too. That's from George. Gloria. Oh, today was such a great time. Thanks for the insight, Prof. I really appreciate it. Thank you to Gloria for your time. I appreciate. And I will appreciate if we can encourage more people to be part of this platform. Because if we have insight to give and we don't see people to talk to, then the insight remains docile. Elvis, it was such an eye-opening session for me. Oh, you're most welcome, Elvis. God bless. Thank you, Gloria. Mr. Ayinde, very insightful and impactful. Thank you, Mr. Ayinde. We didn't see you being active. I guess maybe you are busy somewhere. It's nice to hear from you. God bless you. Yes, who is speaking?
It's Mr. Ayinde.
Mr. Ayinde.
Yes.
It's nice to hear your voice.
Yeah, so I actually follow everything vividly.
Okay, that's interesting. That's quite relieving to hear that. Yes.
And perhaps maybe you will also help us with the slide and the topics you have actually seen. I'm actually using my phone. I'm finding it
Okay, your
phone.
phone.
Yes, my
Okay,
phone.
okay.
So to navigate from I am using ChatGPT for quite some time, so I know how to mix of ChatGPT very well. And then I also make use of digital notebook as well. So I cannot. It is fine. I'm finding it difficult to navigate between the two because of my phone.
Your phone, I see. It's quite suggestive.
So I will, based on just what you actually said, that if you're actually interested in any of the subject topics, that you can collaborate together. So I'm much more interested in that. What I would just say from you is maybe after the whole lecture, you're supposed to drop the slide and
the slide, no problem. I will drop the slide. I'll drop
and
this on our WhatsApp group immediately.
all right. All right.
Then I will also try to put it.
All right. So anything I'm able to do, I'll be sending it to you, sir, for your
No
guidance.
problem, no problem. So that's quite interesting.
Thank you very much.
So, so from Mr. Jonathan, is anything the best
Yes, sir.
webinar ever attended? Thank you, Mr. Jonathan. That's good to hear. Thank you too. Kevis, I've been using Fed simulation and my lesson have been seriously enriched. Wow, that's quite interesting to know. Though today we didn't feature Fed simulation. Thank you for bringing it up. Fed's interactive simulation, resident at University of Colorado in Boulder, is one of the major sponsors of this program. Sponsor in what sense? You know, we've been on a Zoom for the past 2 hours and few minutes, and we don't have any cutoff. This is called FET Interactive Simulation. I happen to be a fellow of FET Interactive Simulation, a concept brought to bear by a Nobel laureate, sometimes in year 2002. And that has been used to enhance learning of STEM subjects over the years. So we also encourage each and every one of us to actually exploit. You have their logo on the last page of the presentation today, so you can actually go online and also exploit. So I'm glad that Ms. Ivis, you are using a pet simulation. That's quite interesting. I'm really, really happy to hear that. So can we take a group photograph before we go very quickly? Please, just on your camera, let's take a group photograph. Please, it doesn't matter. Please, just doesn't matter where you are. Just on your camera briefly, let's have a group photograph. Yes, I'm waiting for us. Okay, that's good. Okay, that's beautiful, Mr. Inde. Mr. Jonathan, we didn't get to hear Mr. Dewapo's voice. Mr. Jonathan, can you also on your camera just 1 minute? Okay. Just one more time. Okay. Just one more time, please. Okay. Hold on. Okay. One more. Can you give a smile? Okay. So it's been a nice time with each and every one of you. And I want to say a big thank you for being part of this. God bless you and enjoy the rest of your weekend. So bye.
Thank you so much. Thank you,
Bye.
Prof.
Yeah, you're welcome. Bye.
Thank you, Prof, and bye.
You're most welcome, Gloria. Thank you.
Thank you so much, Prof, for the privilege. Always.
Thank you, Mr. Ivis. God bless you.